All right, how's it going? It is June 9th, 2023, beginning of summer. Oh. Um, so I'm still working, trying different things. Son's still complaining about bad miles per gallon. So today I'm going to test the 4-pin coolant temperature sensor. It's on the back of the head. I'll show you. Right there. This is a 92 Mercedes W124 with an M103 6-cylinder engine. And these are the sensors on it. If you have one of these cars, a later one, or earlier ones, they change these sensors around. I mean, they're basically kind of the same sensors, but they just change things around. So you've got this 4-pin right here, and it's they're all submerged right into the coolant. And this one feeds information to the computer, the fuel injection computer that's back here, on how cold the engine is, how warm it is, and this computer will adjust the fuel trim. It'll give it more fuel when the engine is cold, just to get the thing started and all that. And if that thing goes bad, this computer might think that the engine is always cold, and so it's always adding more fuel and affecting your gas mileage. And that's what I was thinking, so I'm going to be testing it today. Then you've got another sensor right here, this blue 2-pin. I did solder a 1,000 ohm resistor. There it is. I soldered that in, I bridged it across, followed directions. And what that does is it tricks the system to turn these fans on earlier. It kind of fools the system. It makes the system think that the car is like really, really hot, super hot, so it turns these fans on. I did trace these wires where they go to, and at least I got one of them goes to the push button control unit for the climate control. And the push button unit on the dash sends a signal over to that fuse box in the back. There's these cube relays, and some of those cube relays activate the fans. These draw a lot of power, so there's, the wire's a little thicker maybe. But they need those relays. They're just little points that open and close type relays. I've taken them apart and tested them. They're okay. They're doing their job. Everything seems to be working on this car. I mean, it's just, I don't understand why the fuel, I've gone through almost every system. But just double checking. And then you've got another sensor right here. It's just a single pin. And that goes to the temperature gauge in the instrument cluster. Yeah. And this is the EZL right here. Right here. And that gets the signal from that 4-pin. It's ignition. This is your diagnostic port. I don't use it very much. Some people do. I've never been able to get much information off of it, but I do use it for the adjusting the EHA valve. So I'm reviewing Fix Your Mercedes guy, and he's talking about the coolant temperature on his car, and I think his car is a smaller engine, but they kind of use the same sensors, so I'm just reviewing. I want to test mine, so let's see.
Channel.
Okay.
Our today's topic is going to be the coolant temperature sensor. The coolant temperature sensor has the task to report the ECU that the engine is whether cold or warm. When the engine is cold, the additional enrichment is needed in order for the engine to achieve the normal operating temperature. You see, when these sensors go bad, then you can have a high fuel consumption.
Yeah, that's what I'm working on.
The temperature sensor is located here.
See, he's got a different engine than mine. He's got
There are two types of these
similar
sensors.
but different.
There is an older one and a newer one.
Yeah.
An older one.
Yeah, it's that. The older
has,
one.
Two contacts, and the newer one has four of them.
I've got that one.
This sensor goes bad after some 100,000 miles. You can check it. In order to check the sensor, you will have to use your multimeter and measure the resistance.
Do crisscross.
As for the older models, you stick a positive into the contact and the negative onto the ground.
That's this one.
And the ground is any metal part of your car chassis. You need to measure on the older models each of the contacts separately and then see the target value. On the newer models, you will have to measure the contacts parallel.
Parallel. Like
one is for the spark and the second one is for the contact.
For the what?
The target value you have to get is 2.5 kilo ohm when the engine is cold.
Okay, hold on.
And when the engine is warm, the temperature falls down so that you have to get 350 ohms.
So, what did he say? When the engine, when the temperature falls down? Come on.
Temperature falls down so that you have to get 350 ohms. About.
Okay, hold on.
150 models. You will have to measure the contacts parallel.
Wait.
One is for the spark and the second one is for the contact. The target value you have to get is 2.5 kilo ohm when the engine is cold.
That's cold.
Is warm,
when it's warm.
The temperature falls down so that you have to get 350 ohm.
So, I'm just writing this down. So when it's warm, should be 350 ohms. Okay. So cold, he's got 2.5 kilo ohms. And then warm is 300. So it goes down. Okay, that makes sense. Okay, I know this can be really confusing, but this is the way I have to kind of work things out. So, on our gauges, on these 300Es, the sweet spot is the 85 mark. So I added 85 to this chart, okay? Converted it. It's funny, at 85 Celsius, 185 Fahrenheit. So I'm doing this so that I can, when I do my test, you know, it helps me determine whether that sensor is good or bad. I mean, you know, you could be testing it where it's super cold out, say 0 Celsius, and it's going to read a higher K ohms. That's 1,000, and you can see where once the temperature starts going up, the ohmage goes down to ohms, not K ohms. Okay. So once the car is warmed up and I retest it, I should be able to get, you know, whatever range, whatever I measure with my, you know, deal and the gauge on how hot that sensor really is. Testing, I think the sensor's okay, because I think it's a new sensor that I replaced when I did the head last time. So you never know, though. Okay, so here we are at the back of the head. There's the 4-pin coolant temperature sensor. I can zoom in on it there. Okay. Then I've got my little trusty. I'm gonna try a couple different ones of these. I got it set to auto ranging on the ohm scale. And then you just I don't know, man. Can you see it? Always frustrating trying to get things to. Okay. Can we do it there like that? So you just go parallel across. So I got 2.1. It's hard to hold them on the pins. They're just so small. Come on, hold still. I got a 2.0. Okay, that's with the small green tester. Try this other one. Set at 20K. Can we see that? Okay. Go parallel across. What's it say? 2.14. Try it the other direction. .10. Okay, so there's the fluke. You got it set to ohms. That's pretty, it's auto ranging also. It's hard to even see it down there. So I got 2.0. 2.1. Okay. I think it's in the ballpark. Let's see if I can you read that? So you got about 85, 86, 82. Let's just call it 83 Fahrenheit. I could convert that. All right. So my son went for a drive, and he got the engine hot. Just at about the 85 mark. $256, 253. Cross it. These probes are so small. 260. 261. Okay, I'm gonna try a different meter. Probes are a little bit thicker. Maybe it'll be easier to hold on those pins, those blasted pins. God. 1. 260 one side. 268 the other side. Okay, now let's go compare our chart and see what it's supposed to be at. Okay, so Fix Your Mercedes says 2.5 kilo ohms. That's 2,500 ohms, right? K is 1,000. And what did I get? I got about 2.1. So I got about 2.1 on all 3 meters, so that's called, this is my unit right here, my car. Now we just measured after the car's been warmed up. These are 2 different meters. This is the small meter and this is the fluke. So these are just ohms, not 1,000 ohms, it's just ohms. 253 ohms. So the engine right now was hot. We measured about 185 Fahrenheit or 85 Celsius. And he's saying that it should be about 350 ohms. So ours is down, really down. Yeah. Once it warms, it falls down so that you have 350 ohms, about 350 ohms at operating temperatures. Okay. So if we're at about 268, yeah, I think the sensor's okay. 247, 325, 268, maybe around here. I think the temperature sensor's okay. I mean, it did go down. It didn't get stuck at this 2.1 or that, you know, that value there, 2000 ohms. If it was stuck at 2000 ohms once the car was warmed up, then you know that the computer is feeding excess amount of fuel to the system and bad gas mileage. All right. Okay, let's look at this again. Okay, so again, here's your 4-pin, and this is the way they measure it. Here, this one to this one, this one to this one. All right, ohms. The temperature sensor and connector are designed temperature signals crosswise in such a way that the connector can be fitted in any desired position. That means the plug that goes there, you can turn it like this and go like this, you can go like this, okay? Note, when testing the coolant temperature sensor, the resistance should be measured and compared 2 times crosswise. Refer to illustration. All right, so I found a page from one of the factory manuals for the gosh darn it, stay there. For the electrical test data for the injection system, you can measure like voltages and stuff, but I'm more interested in the coolant temperature sensor, which is right here, and it's the 103 engine. It's kind of blurry because I had a really hard time finding this online and copying it. I had to do a screenshot because it wouldn't let me copy it. So coolant temperature sensor, 20 degrees Celsius. It should be at 2.3 to 2.8 K ohms. That's 2,300 ohms, 2,800 ohms. Okay, so on cold, we've got 2.1. They're saying 2.3 to 2.8. I mean, it's really close, you know. There's a lot of variations too because of the thing reacts to temperatures, and you know. So that was a measurement at 2082F. I measured with the point and shoot laser. That's 27 Celsius. It's not 20. So, you know, there's that to figure in, if you can figure that out. Anyway, so mine's really close to this ballpark, 2.1. I mean, you know. And then at 80 Celsius, should be 290 to 370. Mine is, I think the highest number was like 268, you know, so the device is doing its thing. It's when it's cold, the resistance measures high. When it heats up, the resistance measures low. And it goes up and down, up and down. And so it's doing its thing. I mean, I replaced it when I replaced the head. Then I, you know, tested some other you know, sensors that I got here like this. You know, I put some, I cooled this off. I just got a piece like some frozen vegetables, you know, and I just stuck this on there and then measured it until I got to the right temperature at 20 Celsius, and it measured okay. And then when it heats up, you'll see it. You can just take a blow dryer. You can put it in hot water. You know, right now it's at 1,000 ohms. And then I turn on the blow dryer to heat it up. You'll see it starts going down. And eventually when it reaches the 80 Celsius mark, and then it's like around 300 something. You know, I got a couple of these. This came out of a old 300 SC. I wasn't sure if it was good or bad, but it tests good. So as long as yours is in the ballpark there, I think it's okay. You know, if you heated it up and it wasn't doing anything, yeah, then that unit's going to be bad and you got to replace it. You know, so when you look at these numbers, I mean, you know, searching the internet, people were saying that then when it's hot, it should be at 350 ohms, right? You know, you don't know. I mean, the temperature just, you know, there's a swing in the temperature and it affects that number there. So I think as long as you're in that ballpark, you should be okay and you don't need to replace it. I'm not going to replace mine because I know that it's not 30 years old. You know, I think I got it from a good German company. Anyways, I'm going to leave that unit alone. I tested it. That's how I tested it. It's kind of, you know, I'm all over the map, but it's hard to find information out on some of these older cars. You know, there's a lot of good information, and then there's information, you know, you're not sure, you know. Anyways, that's my take on it. Test yours if you're having issues, you know, and you can do the same thing with the 2-pin sensor. You know, you can put it in hot water, cold water, take it out. But when you take those things out, you got coolant dripping all over the ground and stuff. So I didn't really want to do that. I wanted to test it when it's there in the car. Talk to you later.